Hello all, welcome to another tech video. Here is an overview of what we are going to learn today. We will learn about application deployment models from traditional deployments to containerized environment, why we need Kubernetes, and the differences between Kubernetes and Red Hat OpenShift. Also, we'll check out the key reasons why we should choose Red Hat OpenShift over vanilla Kubernetes. We will also talk about the built-in observability options available, and also using IBM Instana. Let's get started. This architecture diagram is good enough to understand the deployment models. We'll talk about the traditional deployments, application deployments on virtual machines, and then containers, and then we'll move on to Kubernetes and OpenShift. In traditional deployments, we have a bare metal server on top of which we install an operating system like Linux, Windows, AIX, etc. And one or more applications are installed on this single server. The problem with this approach is the lack of scalability, high availability, security, application upgrade issues, etc. What happens if the base server crashes? How to handle a heavy traffic, say on a Black Friday sales? How to isolate application so that if a hacker gets into one, it should not impact other applications sharing the same server, especially if it hosts a database system. Another issue is with application upgrades. How to upgrade the application with no downtime. Also, each application may need a different set of bins and libraries. How to handle that? So there are many limitations with this approach. Virtual machines are a solution for this. One solution is to use Type 2 virtualization software. That is on top of your existing server, which already has an operating system like Windows or Linux running, enable hypervisors like Windows Hyper-V, VMware Workstation, Oracle VirtualBox, etc. However, for an enterprise level, this is not a good option and not much secure. Another solution is to install Type 1 virtualization software like VMware ESXi, Proxmox software, etc. directly on the hardware, and to create multiple virtual machines, each having its own guest OS. Because bare metal hypervisors are isolated from the attack-prone operating systems, they are extremely secure. Now, having multiple virtual machines running on the host, each application can be run on a different VM and is isolated. Application which needs a Linux OS can run in a virtual machine which has Linux as guest OS, and similarly for Windows and others. Even though we have achieved isolation, we are wasting resources as each VM has a dedicated guest OS, compute, memory, etc. Also, scaling the application would need creating more virtual machines, which is not that easy and involves high resource consumption. On a side note, another solution could be using the cloud, where we can enable auto-scaling, cloud bursts, etc. using cloud virtual server instances, cloud functions, etc. This is a good solution for certain type of applications, which I'm not going to cover today. Shall do a separate video on that. Now getting back to the limitations of just having all the virtual machines. Wouldn't it be better if we can have multiple applications running all on the same server, but at the same time isolated from each other, sharing the compute, memory, and even the operating system? This is where containers come into picture. As you can see in this architecture, we have the hardware on top of which we can install an operating system, preferably container-optimized operating systems like Red Hat Core OS, Google Container Optimized OS, etc. All we need extra is a container runtime like CRI-O, Containerd, etc. That's all. We can now run multiple containerized applications on this same host server. But what is a containerized application? An application can be containerized by encapsulating only the application code itself with all its dependencies like binaries, libraries, and config file needed for it to run. By doing this, all it needs to run is a container runtime, and it will utilize the same host OS kernel. As you can see, we removed the guest OS part, and we are sharing the host OS kernel. So containers are very lightweight and easy to scale up and down to meet the demands. Now we have achieved our goal of running multiple containerized applications on the same host. What if we have to scale up horizontally? We would need a distributed system or a cluster of servers. By having a cluster, we can achieve high availability and scalability from the host server level itself. However, maintaining a cluster and then running containers in the cluster involves a lot of manual work and human cost. This is where container orchestration comes into picture. Without an orchestrator, you will have to manually create and maintain a cluster. How to add more compute to an existing cluster? What happens if a container crashes? Will it be automatically recreated? How to scale up your containers, both vertically and horizontally. So as you see in this list, more manual work involved. Or maybe write tons of custom scripts to achieve these objectives. This is why we need container orchestrators like Kubernetes. Let's learn more about Kubernetes and then compare it with Red Hat OpenShift. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. It has a distributed cluster architecture. It enables multi-tenancy via control plane and data plane isolation. Say, for example, in Kubernetes SaaS offering by a cloud provider, you may be sharing the same control plane with other customers. This is not the case if you have a dedicated offering. Another example of isolation of projects resources is using namespaces. Say you have multiple projects within the same company, one for an HR tool and one for a shop floor systems. You can provide access to the HR team to only their namespace. Kubernetes also enables auto-scaling of containers, replication of application deployments across multiple nodes of a cluster. You can set up ingress to route user traffic to their corresponding backends without having to set up multiple load balancers, etc. If Kubernetes provides all these benefits, why we need Red Hat OpenShift at all? OpenShift is based on Kubernetes open source project and extends the platform with features that brings a robust, flexible, and scalable container platform to customer data centers, enabling developers to run workloads in a highly available environment. So OpenShift is enterprise Kubernetes with advanced support from Red Hat. It provides enhanced security and has built-in logging and monitoring. OpenShift also provides pipelines for CI/CD and a secure image registry. Red Hat OpenShift also provides tools like source-to-image (S2I), whereby you can create and deploy a containerized application directly from the source code, hosted on a repository like GitHub. You do not have to worry about creating Docker files, etc. Source-to-image will automatically create images and push it to the OpenShift image registry. Another interesting addition is routes. OpenShift routes allows you to expose a service at a public URL. Routes can be created as secure routes with encryption. Other features of OpenShift includes OpenShift Service Mesh, image streams for build automation, integrated storage plugins and classes, say storage plugin for AWS Cloud, IBM Cloud, etc. The Red Hat OpenShift product family includes Red Hat OpenShift Container Platform, Red Hat OpenShift Dedicated, Red Hat OpenShift Online, Red Hat OpenShift Kubernetes Engine, and then finally, Red Hat OpenShift Code-Ready Containers. Code-Ready containers are completely free and can be installed on a laptop for learning and testing. Another interesting tool I want to talk about is cost management for Red Hat OpenShift. Cost management tool for OpenShift is a SaaS offering that is included at no additional charge as part of your Red Hat OpenShift subscription. This service gives you visibility into your costs down to the project level across on-premise or public cloud environments for both infrastructure and Red Hat OpenShift. Here is a quick view of the cost management console. As you can see, I have filtered the cost based on AWS Cloud. We have a total cumulative cost of $812, and the top services includes EC2 instances used for OpenShift. Observability overview. OpenShift has built-in monitoring, logging, and observability tools. Not all of them are enabled by default, but can be easily installed using Red Hat certified operators from the OpenShift Operator Hub. Note that these operators are certified and supported by Red Hat OpenShift team. We have OpenShift Web Console, built-in monitoring, alerts, and matrices. The Network Observability Operator, the Node Observability Operator, OpenShift Service Mesh, Red Hat Advanced Cluster Management, Red Hat OpenShift Logging. We can also use IBM Instana and other third-party observability tools. Here is a quick view of the OpenShift built-in dashboard. Now let's get started on IBM Instana, one of my favorite observability tools. Here is my IBM Instana console, and I'm filtering with my OpenShift cluster name. There is no data available at the moment. Let's go ahead and install Instana Operator on our OpenShift. In the OpenShift Operator Hub, let's search for Instana and choose the certified operator from the list. Let's do the prerequisites. Create a new Instana agent project and then enable privileged security context for agent service account. Now, before installing the agent, copy the Instana agent.yaml and replace with your Instana agent key. I have pre-created the YAML, but before applying the YAML, let's install the operator itself. Select the default settings and click Install. The operator is now installed and ready for use. We can now apply the Instana agent YAML to OpenShift, which will create the necessary agent pods. Let's select the project Instana agent from the dropdown, and you can see the Instana agent pods are created. If we go back to the Instana agent console now and refresh, our OpenShift cluster should be there. The cluster is now available, and we can start observing. So we were able to install one of the best observability tools with a few clicks. That's all for today. Thanks for watching.